What's up, everybody? It's Dan from Sage Math Tutoring, and back with a video. I have an eighth grade student who is working on these concepts, so I want to make a video about these problems. So let's dive right in. All right, let's look at this first one. Which of the sets shown includes the elements of the set C that are both negative numbers and multiples of 4? Well, we want to understand that we're looking for negative numbers, right? So that's a negative number, that's a negative number, that's a negative number, that's a negative number. But it's not just negative numbers that we're looking for. We, of course, are also looking for multiples of 4 as well. This is a multiple of 4, this is a multiple of 4, and that's it, I think. Now, negative 34 is not divisible by 4. It is the case that 4 times negative 8 is negative 32, but negative 34 is not divisible by 4. Negative 2 is not divisible by 4 either. So for my student watching, just know that when they say multiple of 4, we're looking for some number that is divisible by 4, you know? Something like 40 would be a multiple of 4, right? Because 40 is divisible by 4, etc. So therefore, this is the answer. Moving on to the next problem. Let's take a look. This one right here. Okay, they want this from least to greatest. Um, hmm, kind of annoying, huh? Well, all right. You could just convert everything to either a decimal or something that kind of looks sort of kind of a little bit maybe like a decimal. So 45 over 11, I mean, that's really 45 divided by 11. Now, 11 goes into 45 four times. That would give you 44. Subtract 44, you have 1. You have this sort of 0 that could drop down. 10 or 11 goes into 10 0 times, so you'd have to drop down another 0. And 11 goes into 100 like 99 times, or 9 times rather. So 4.09. So really, 45 over 11 is 4.09. This is obviously 4.5. 20, radical 20, the way to process that is to acknowledge various perfect squares. So for example, 1 squared is equal to 1, 2 squared is equal to 4, 3 squared is equal to 9, 4 squared is equal to 16. 5 squared is equal to 25. 6 squared is equal to 36. Now, correspondingly, you could say about the green numbers that these green numbers here are what we would call perfect squares. And you could kind of investigate that the square root of 1 is therefore going to be this 1. The square root of 4 is going to be 2, right? And that's kind of based off of this right here. The square root of this number is equal to that number. Um, and you can kind of continue with that. You could say the square root of 9 is really equal to 3. You could say that the square root of 16 is really equal to 4. You could say that the square root of 25 is equal to 5. So we could, of course, keep going, but I'm just illustrating the reasoning process here. So for my student watching, understand you don't have to do any of this. I just want you to understand something. And that is that the square root of 16 is 4, and the square root of 25 is 5. Okay. This is asking us for the square root of 20, which is kind of in between those, right? The square root of 20 would be in between. So we know it's going to be 4 point something. Um, so that's interesting. Now, it really seems like 20 is right in the middle of 16 and 25, but the reality is that 20 is a little bit closer to 16 than it is to 25, because 20 is 4 units away from 16 and 20 is 5 units away from 25. Now, if 20 was right in the middle, then maybe we could say that the square root of it's 4.5. But since it's a little closer, since 20 is a little bit closer to 16, it's probably going to be a little bit less than 4.5. Now, when I use a calculator, I'll use approximation symbols here. When I use a calculator to look at what the square root of 20 is, I get that it's approximately 4.47. Now, I'm not so sure if the teacher wants you to use a calculator for that. That might be best to use a calculator. But if you're not allowed to use a calculator, I would use this reasoning to recognize that whatever this is, it's probably going to be a little bit less than 4.5. And that's important information because we need to know that it's actually less than this number, right? So looking at this one, first of all, what is 45 divided by 4? Well, that would be 1, subtract 0, drop the 5 down, and 4 goes into 5 once, and then that's 4, and then you subtract, and then you would drop that 0 down. 4 goes into um, 10 two times, and so on. So this would be 11.2-ish, right? There's probably more to it than that. But the reality is that we're square rooting this number, right? And we already saw that the square root of 9 is 3 and the square root of 16 is 4. So this is the square root of 11.2 something, which is in between. So that's going to put it in between 3 and 4. So that's going to be 3 point something. Um, so if we're going to go from least to greatest, well, this is the first one to list because it's um, 3 point something. The next one to list would be this one because that's 4.09. The next one to list would be this one because that's less than 4.5. And then finally, this one is 4.5. So that's how I would list it personally. All right, so that one, in my opinion, is a relatively challenging one, I have to be honest, especially if you're not allowed to use a calculator. Now, if you are allowed to use a calculator, then it makes it a lot easier because you can literally just be like 45 divided by 11, oh, 4.09. Uh, square root of 20, oh, 4.47. Square root of this, oh, whatever that is, 3 point something, right? You'll be able to just kind of write down all the decimal equivalents based on the calculator. But if you can't have a calculator or you can't use a calculator, you need to be clear about this situation here. Okay. And the fact that radical 20 is between radical 16 and radical 25, the fact that radical 11.2 is between radical 9 and radical 16. All right. So hopefully that makes sense. This here, let's see. Which of the following will result in a rational number? Select all that applies. So once again, just know that a rational number might be best understood. I kind of went through a breakdown recently with my student about this, with this whole big flow chart talking about real numbers, integers, et cetera, et cetera. But I think for the purposes of this video, let's just get clear on rational numbers and irrational numbers. Now, I'm going to define rational numbers as not irrational, which is not a good definition, generally speaking. But nonetheless, irrational numbers are kind of easy to spot and easy to understand. So if it's not an irrational number, then it's going to be a rational number. Now, famous irrational numbers are pi, that's like 3.14. Any square root of a non-perfect square like these would be irrational. Now, even radical 6 would work. So if it's the case that you were to plug these into a calculator, it would give you some decimal that goes on forever. The reality is that even pi goes on forever, and it would be utter chaos. Okay, it would be chaos going on forever where there's no repeating pattern at all. It's just like a whole bunch of gobbledygook numbers. Okay, now the same would actually occur if you were to put square root of 2 into the calculator and all of these. So for now, just understand that irrational numbers very often are square roots of non-perfect squares, um, such that when you plug it into a calculator, it would pump out this number that has like this decimals that's gone forever, and there's no repeating pattern in the decimals. Now, in contrast, rational numbers are not like that. Even a square root of 4 is just 2, right? And that's a nice number. That doesn't have a decimal that goes on forever. So anytime you take the square root of a perfect square, then it's going to be rational because these always give you nice numbers, right? 25, that's rational. But other rational numbers, it doesn't always have to do with perfect squares. It could have to do with just the fact that it's 1/3. That's kind of a nice number. Even if you turn that into a decimal, yes, that would be a repeating three forever, but that's a repeating pattern forever. So rational numbers always have a repeating pattern or the decimal stops somewhere. You can think of it that way. 10 is rational. Any of the integers, -10 is rational. Okay. So if it's a crazy number that gives you a crazy decimal, it's irrational. Okay. Now, I will say that let's just be very clear about something else. Anytime, hmm, all right, I'm going to do another little presentation here. Let's see. I can already see where things are going. So, anytime you have a rational number plus an irrational number, that's going to give you an irrational number. Anytime you have a rational number minus an irrational number, that's going to give you an irrational number. Anytime you have an irrational number minus a rational number, that's going to give you a rational number, an irrational number, pardon me. That's going to give you an irrational number. Sorry about that. Okay, so notice how when you have addition and subtraction, the mere presence of an irrational number causes it to be irrational. Now, for the record, an irrational number plus a rational number would also give you an irrational number. It's just that the order doesn't matter with addition. So when it comes to these, I'll actually bring them underneath. So it's also true that we can say the following, and that is that anytime you multiply a rational number times an irrational number, you will get an irrational number. Anytime you divide a rational number by an irrational number, you will also get an irrational number. Anytime you divide an irrational number by a rational number, you will get an irrational number. And reality is I actually don't need this. It is the case that if you multiply a rational number times another irrational number, a rational number times an irrational number, you're going to get an irrational number. It's also true that if you switch the order where you multiply an irrational number times a rational number, you would also get an irrational number. So these are sort of facts to know. It's something to note that the mere presence, once again, of an irrational number in these situations causes it such that there's going to be an irrational number after you perform the operation. Now, we should also note that anytime you have rational numbers to deal with, we should look at that. Okay. And we're going to look at that right now. So imagine you're only dealing with rational numbers. Well, there's a few scenarios to take into account in those scenarios. Um, if it's the case that you do a rational number plus another rational number, you're going to get a rational number. If it's the case that it's a rational number minus another rational number, you're going to get a rational number. If it's the case that you do rational times a rational, you're going to get a rational. And if it's the case that you do a rational divided by a rational, you're going to get a rational number. So whenever there's no irrational numbers being introduced into the situation, the output is going to be rational. Okay, so that was a lot of boring information. Let's take a look at the problem now. Um, this is rational plus irrational. Why is this irrational? Because 12 is not a perfect square. And I had already said that anytime a number is not a perfect square and you take the square root of it, it's going to be irrational. So that's an irrational number over 3, okay, which is going to be irrational also because irrational divided by rational is also irrational. So this is irrational. This is rational. We have rational plus irrational. So that's irrational. Over here, we have rational times irrational. So that's also irrational. Over here, we have rational minus rational. And why is that? Because the square root of 36 over 3 is really the square root of 6 over 3. Now, let's think about it. The square root of 36 is 6. So that's going to be 6 over 3. And I think everyone can see that that's just 2. So the square root of 36 over 3 is secretly just 2. So that's rational minus rational. So that makes this rational. This is rational divided by rational. So that makes this rational. Looking at number 4, what is the value of x in this equation? Straightforward algebra, which is nice. Distributing this would be a good idea. So 3 times 2x is 6x, 3 times negative 5 is negative 15, minus 4x plus 8 equals negative 1. We have a like term here, double underline. We have a like term here and here, single underline. 6x minus 4x is 2x, negative 15 plus 8 is negative 7, equals negative 1. Adding 7 to both sides gives us 6 over here. Dividing both sides by 2 gives us 3. So that is the answer. Okay, straightforward. Right here, the sum of 3 consecutive even integers. So the way to represent 3 consecutive even integers is the lowest one you could call x, the next one in line you could call x plus 2, and the next one in line you could call x plus 4. Now, what do we mean by consecutive even integers? Well, something like 2, 4, 6. Uh, those happen to be consecutive even integers. Other examples might be 10, 12, 14. Even integers such that one follows right after the other. So I think we can see that these are all spaced out by 2, okay? And that's accounted for here. So if you start with the lowest one, the next one is going to be whatever that lowest one was plus 2. And then the next one is going to be whatever that lowest one was plus 4, if that makes sense. For example, 6 is clearly 2 plus 4. 14 is clearly 10 plus 4. So hopefully that makes sense. Um, you could set up an equation right away based off of the information they gave us. Apparently, the sum of these, which is what you get when you add, is 72. So the first one plus the next one plus the next one is going to be 72. Well, what is the first one? It's x. What is the next one? It's x plus 2. What is the next one? It is x plus 4. And then I use parentheses to just show that it is 3 numbers ultimately being added together, but in reality, we don't need the parentheses, or you could think of there being an invisible one that gets distributed, and then the parentheses go away, but all the values retain their values. So let's just rewrite it such that there's no parentheses, and we have a double underline like term situation. We have a single underline like term situation. So that's 3x plus 6, and that equals 72. Subtracting 6 from both sides would give us 66. Dividing both sides by 3 would give us 22. So that's that one. Um, let's see. Looking at this one, Latanya buys 5 yards of blue fabric, 8 yards of green. The blue costs two more per yard than the green. She pays a total of 62. What would be the combined cost of 1 yard of blue fabric and 1 yard of green fabric? So we could say B is the cost um, per yard of blue, and G is the cost per yard of green. And ultimately, we want to find the combined cost of 1 yard of blue and 1 yard of green. So ultimately, our goal is to add B plus G and find out what that is. Well, in my opinion, it would be nice to know what B is. It would be nice to know what the cost per yard of blue is. And then we could just put it here. It would be nice to know what the cost per yard of green is, right? And then we could just put it here, and then we could just add those, and then we would have it, right? So we're sort of hoping that there is a way to find out what B is and a way to find out what G is. Now, they essentially just give you clues as to how to find this information. For example, there's a big clue, I would say, really here, where, or at least this is like a foundational piece of it, where the blue fabric, which is B, apparently costs two more per yard than the green. So, in other words, B is the same as green. It's just two more, so plus two on top of that. Now, the moral of the story with that equation that I just wrote down is that anytime you see a B, you could just replace it with a G plus two. So that's just a mental note that we could make because B is the same as G plus two. So therefore, anytime we see a B, we can just replace it with G plus two. Now, moving our attention to another part, which is this green information, and we have more green information down here. Apparently, this person bought 5 yards of the blue and 8 yards of the green, and the total cost ended up being $62. So why don't we make an equation out of this that sort of represents the cost of things? So, I think we understand that the cost of the blue fabric plus the cost of the green fabric is going to equal the total cost, of the whole thing, right? Well, she spent 62, so that's the total cost. The cost of the green fabric is going to be 8 times however much green fabric costs per yard, which is G. The cost of the blue fabric is going to be whatever the blue fabric costs per yard. So that's 5B. And we'd be adding those, right? So, uh, based off of this information, she bought 5 yards of blue, 8 yards of green. And by the way, she paid 62 for all that. Well, that's going to be 5B plus 8G equals 62. Okay. 5B is the cost of the blue fabric, total cost of the blue fabric. Um, 8G is the total cost of the green. In fact, I'll write total cost of the green, and this is total cost of the blue. So we've got quite a bit of information here. Now, let's not lose sight of our goal. Our goal is to find out what b plus g is. Now, unfortunately, that's going to be tricky here. This is sort of an annoying equation, partly because there's two variables. Okay, there's two variables. So we have to find a way to make it so that there's only one variable that we're dealing with, and that's where this comes in. Remember how I said anytime you see a b, you can replace it with a g plus 2. So that means that this can be replaced with a g plus 2. So why don't we go ahead and instead of writing b, we can write g plus 2. And everything else stays the same. All right. Then we can acknowledge that, of course, you can distribute here and here. We end up with 5 times g plus 10 plus 8 times g equals 62. At that point, double underline like terms, 13g plus 10 equals 62. And then subtract 10 from both sides. You have 13g equals 52, and then divide both sides by 15, and you get 4. So we just discovered that the green fabric costs $4 per yard. Now, you might be saying, okay, great, but at the end of the day, I want to do B plus G and find out what that is, but we don't have B yet. But the good news is we can find B pretty easily now because we have another equation that says that B equals G plus 2. Now we already know that G is 4, so we could say that B equals 4 plus 2, and that is equal to 6. So clearly B equals 6. Once again, we want to know what is B plus G. So that will be 4, or I should say 6 plus 4, and that equals 10. And that's the answer there. Now, I would say that's a relatively challenging problem. This is ultimately what they would call a system of equations type problem, where we needed to use the substitution method. For my student watching, I would say definitely study this, maybe try it again on your own, see if you can recreate what I just did. But that's how you do that one. All right. Looking at this, how many solutions are there to this? Well, we need to understand that anytime you have sort of a scenario like this, where that's the same and that's and these constants are the same, well, that's infinite solutions. Anytime you have a scenario where um, these are the same, but these are different, then that's no solution. And any time you have um, these these right here being different, I'll use a different color for that. If these are different, the terms with the X in it are different, then that's one solution. Now you might be wondering, when it's one solution, what about the constants? Well, they could be the same or different. It actually doesn't matter. The moment you see that the X terms on both sides of the equal sign are different, you know it's going to be one solution. So, um, in my opinion, that's like the best information to know for this one. So, notice how this sort of relies on us having a nice simple left side here that we could look at, a simplified right hand side of the equation that we could look at, and then we could compare the two sides. Well, in this scenario, unfortunately, they did not simplify it for us because we might want to distribute here, you know? We might want to distribute that. So let's go ahead and do it. So we have 5x plus 2 minus 2x plus 1 equals 3x plus 4, double underline like terms, single underline like terms. We have 5x minus 2x, which is 3x. The 2 plus 1 gives us a 3, and that equals 3x plus 4. Now, this is a scenario where these are the same, but these are different, and that is something like this right here, right here. And that's no solution. So that's A. Hopefully that makes sense. That's number 7. Looking at number 8. Let's see. Corey combines X pounds of herbal tea at 12 per pound with 8 pounds of regular tea at 9 per pound, makes a mixture that averages 10.15 per pound, 10.50 per pound. Write an equation that models this situation. Well, for mixture problems, we have this scenario. Okay, this is the way I like to do these. Now, this is sort of a mixture problem. Um, we have like the first mixture plus another mixture, call that mixture 1 plus mixture 2, and we could call this like the total mixture at the end of mixing everything together. Now, for this, I'm going to say we're going to put quantity on top and we're going to put money under that. So, with regards to quantity, um, this will be the mixture pertaining to herbal tea. So, we have X pounds of that. We have X pounds. We'll make the quantity red and the money part blue. And that's going to be $12 per pound. Okay. Now, for the other mixture, we have how many pounds? 8 pounds. They actually told us that for the mixture pertaining to regular. So that's 8 pounds. And the cost associated with that is 9. And over here, the total pounds of the final mixture, and in fact, I think I'll call this the final mixture. I like that better. We're going to call this the final mixture. So the total pounds of the final mixture is going to be this amount of pounds plus this amount of pounds. So that's X plus 8. Okay. Now, um, the cost per pound of the final mixture is 10.50. All right. And we'll be clear about this, that the middle part, or this blue part rather, is cost per pound. All right. But then at the bottom, you want another thing. All right. This is a good way to do mixture problems. At the bottom, you want to multiply these. So that's going to be 12x. This is going to be 72. And this, interestingly, is going to be 10.5 times this debacle of x plus 8. All right. And it's this bottom part that gives you an equation that you could then use to solve for x, aka an equation that models the situation. So that's 12x plus 72 equals 10.5 times x plus 8. Notice how they're not asking us to solve this. They just want the equation, and we just did that. So that's how I like to handle mixture problems. And I would suggest that. I would recommend that. Okay, let's see. So number 9, finding the value of x in this equation. Let's take a look. Um, I'm a fan of getting rid of annoying denominators. So we have this denominator of 4 here. We have another denominator of 4 there. And one way of getting rid of these denominators, because to be honest, no one wants to distribute 3/4 into this. It's going to be annoying. So I would recommend the hovering strike method, which is to find the least common denominator, which is we could say the least common multiple of these denominators. So the least common multiple of 4 and 4 is 4. Okay. It's not always that way, when you're finding least common multiples. But it is the case that the least common multiple of 4 and 4 is indeed 4. So what you do is you multiply everything by 4. Okay, multiply both sides of the equation, we could say, by 4. Now, the way that I like to represent that is to essentially multiply each sort of like entity, for lack of a better word, by 4. Now, this is an entity, this is its own entity, and this whole clump right here is an entity. Now, what we're going to be doing is multiplying all of that by 4. So this gets multiplied by 4. This gets multiplied by 4. This gets multiplied by 4. And in doing so, what happens is the 4 here cancels with the 4 there. The 4 here cancels with the 4 there. Now, there's nothing underneath this 3x with which to cancel that force. So we are sort of like stuck with that situation. Now, let's take a look at what remains after that hovering strike. Okay, so the 4 knocked out the denominator here. This 4 knocked out the denominator here. So let's take a look at what remains. Well, what remains is 3 times 6x plus 1 minus, let's be careful, 12x equals 1 times 2x minus 1. So notice how we just effectively got rid of the annoying denominators. At this point, yes, you can distribute because it's less annoying now. And we have 18x plus 3 minus 12x equals, and when you, of course, distribute that 1, it's going to just be 2x minus 1. And let's see, like terms on the left, that becomes 6x plus 3. And that equals 2x minus 1. Subtracting 2x from both sides gives us 4x plus 3 equals negative 1. Subtracting 3 from both sides gives us 4x equals negative 4. Dividing both sides by 4 gives us negative 1, and that is the answer to that one. Now, I want to just draw your attention to the fact that when we multiplied this 4 times this whole entity, notice how the parentheses stayed the same. So what was inside the parentheses went untouched, whereas this thing on the outside got affected. So you do want to sort of remember that if an entity includes like parentheses like this, and there's sort of the fraction that's on the outside, the denominator you're trying to get rid of, this 4 only in a sense gets applied to this number. Okay, so that's that one. Hopefully that makes sense. Okay, looking at the next one, solve the equation S blah 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 for the variable W. So my student watching and I did this recently where we want to solve for the W, so that's this red W. Now that is a matter of getting the red W by itself. That's the goal, is to solve for W, right? Now, in order to solve for that red W, again, you have to get it by itself. I say we leave it on the right and we'll get it by itself on the right. Now, in order to get that red W by itself, you have to get rid of all the other stuff. And you always have to start with the stuff that's far away. So what's far away? The A. So we start there. So, of course, subtracting A from both sides, that would give us S minus A, and that would cancel. And then we would have LW. Of course, we want to get the W by itself, so we would have to divide both sides by L, and then you have W equals S minus A over L. And believe it or not, that's the answer. So this one right here. Okay, then velocity v, blah, 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 object r units from Earth, center have order to escape gravity is given by that, where g is a constant solver. Okay, so we're just solving for that big capital M there. Now, in order to get the M by itself, you have to get rid of the stuff that's far away from the M. Now, that might not be obvious here, but the thing to treat as far away from the M, again, the goal is to get the red M by itself right now. The thing that should be treated as quote unquote far away from the red M is this R, okay? Because it's on the bottom, okay? It's in the denominator. So in order to get rid of that R that's in the denominator, you have to multiply both sides by R. That would cancel these. Next thing you know, you have this all by itself. And then you have the r times v squared over here. I think my student watching understands at this point we need to get rid of the 2 and the g. Now it is the case that you can do that move at the same time. So that would be 2g divided by 2g. Cancel, cancel. And then the next thing you know, you have rv squared over 2g, and that does indeed equal that red m. So rv squared over 2g is the answer. So that's that. Problem number 12, write the formula for the volume, blah, 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 in terms of H. Okay, so there's a two-part problem. Let's just do that first. Writing this in terms of H. Now, I am a fan of getting rid of fraction coefficients by multiplying both sides by the reciprocal. And that would look like multiplying both sides by 3 over 1. Cancel, 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 cancel. Next thing you know, you have this completely by itself. And of course, on the other side, we would have 3v because 3 over 1 is really just 3, so it's 3v. Then, of course, we have to get rid of the s squared. Everyone watching probably understands that's just a matter of dividing both sides by s squared. Next thing you know, you have h equals 3v over s squared because those cancel. Now, I can already tell this is one of those problems where they're going to ask us to now use this. In a sense, we just created a nice formula for ourselves that could be useful. All right, so let's take a look at what they want. Then find the height h of a square prism with the volume of V equals 60 and side lengths of 6. Okay, exactly. So we are just going to plug in that information. So it's going to be 3 times some number all over some number squared. So the big V here, according to them, is 60. So fine. And then the little s that's getting squared is 6. Fine. And then we end up with 180 over 36, and that is 5. Okay, so that's 5. And the formula, they are asking for the formula. So for my student watching, it should just be this, right? Okay, so that is that one. Looking at the next, solve the inequality. So let's do that. Solve the inequality. So treat it like algebra. Distribute, 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 distribute. Negative 2x plus 6 minus 4 greater than or equal to 3x minus 5x plus 5. Like terms gives us negative 2x plus 2 is greater than or equal to negative 2x plus 5. Um, and then these cancel. Okay, now how do I know that? Because we could add, of course, 2x to both sides and they would cancel, and then we would just be left with 2 is greater than or equal to 5. So that is an unusual situation where unusual. That's an unusual situation where the terms that have x in it canceled out. You know, very often we're able to solve for x, right? But now the x's are gone, and we're just left with this. Now, this is an inequality. Now, It's not the end of the world if that happens, okay? But you do need to kind of look at what remains after that and just ask yourself, does it make sense? Well, does it make sense that 2 is greater than or equal to 5? No, in no world is 2 greater than or equal to 5, so we would say no solution to this. All right. Now, another way of seeing it for my student watching is that there's no value of x that would ever make this side greater than or equal to this side. All right. So I'll say that again. There is no value of x. There's no possible value of x that could ever make this side greater than or equal to this side. It doesn't matter what x you plug in. You could plug in 0 for x, you could plug in 3 for x, you could put in negative 500 million for x, and under no circumstances at any time ever will this side of the inequality be greater than or equal to this side. So that's why there's no solution. Now, some of you might be wondering, well, what if we ended up with a true statement? For example, what if the inequality was positioned in the other direction, where maybe the original situation was the following, um, such that it's, less than or equal to, then we would have ended up with this. Now, what would that have meant? Well, that would have meant that this is a situation that is true. So 5 is indeed greater than or equal to 2. So whenever you have a scenario at the end of the x's canceling where it's true, well, then it's infinite solutions. Okay. Now, what does that mean? That means x could be any number, and this side will always be less than or equal to this side. So, in other words, you could plug in anything for x, and this side will end up being less than or equal to this side. That's what that means. All right. Um, this one here, treat it like algebra, at least at first. Negative 2x, distribute the 5 plus 5x minus 10 is greater than 7x minus 6. Like terms on the left gives us 3x minus 10 is greater than 7x minus 6. Subtract 7x from both sides gives us negative 4x minus 10. Um, is greater than negative 6. Add 10 to both sides gives us negative 4x is greater than 4. Divide both sides by negative 4. Now let's be very careful about this. We're about to divide both sides by negative 4. Anytime you divide both sides of an inequality by a negative number, or anytime you multiply both sides of an inequality by a negative number, you have to switch the direction of the inequality symbol. So we are dividing both sides of the inequality by a negative number. So therefore, um, it would be x is less than negative 1. So hopefully that makes sense. When you graph it, draw a number line, note the critical value, and then note whether or not it's going to be an open or closed circle. In this case, it's open because there's no underline underneath that inequality. And then note which direction the arrow goes. There is sort of a trick that says anytime the variable is on the left in this sort of final inequality thing, um, you can kind of treat this like it's an arrow. See how it looks a little bit like an arrow pointing to the left? So that would be the answer. Okay, so that's that one. Um, Solving a compound inequality right here. Okay, well, they're using the word and, all right, and we're just going to kind of make a mental note of that because when you graph the solution, You just have to be sort of clear about the difference between what you do with and the difference between what you do with or. So, for now, the good news is you can just kind of solve each of these separately. So distribute 2x minus 4 plus 7 greater than -1. Like terms gives us this. Subtracting 3 from both sides gives us this. And dividing both sides by 2 gives us that. Over here, subtracting 5 from both sides gives us that. Dividing both sides by 4 switches the inequality and then gives us -1. So we have that, and we have that, and we have the word and. So I will once again remind us that we are dealing with the word and. Now, why is that so important? I recommend doing a thing where you have the two critical values. We have a -2 and a -1. I would recommend doing rough draft sketches before you commit to the final draft sketch. We have the red box answer and we have the blue box answer. The red box answer has an open circle hovering above -2. Great, it's clearly going that way forever. The blue box answer has an open circle positioned at -1 and it's clearly going that way forever. Now, notice how my rough draft sketches are hovering above the black final draft number line. Now, the word and concerns itself with where are the rough draft sketches double stacked? Do you see how they're only double stacked here? They're not double stacked here. There's only one arrow here. They're not double stacked here. There's only one arrow here. But here's the region where you have an arrow over another arrow. So that is what we are concerned with is the double stacked area, and then that's going to be your final draft sketch, and that's the answer. So the final answer, in terms of graphing at least, is this yellow thing that we just drew. Notice the open circle and the open circle. Okay. Um, and to be clear about the open circle, the reason this is an open circle is because hovering above -2, it's not double stacked. Right? It's not double stacked there because this is empty. So therefore, since we're only graphing the double stacked region, this would also be empty, right? Same could be said for that. Okay, so that's that. Get rid of all that. So let's see. Write a compound inequality for the graph below. That's going to be very easy because you can really just think that, or say that x is between things, namely -4, -1. Now, there is a closed circle there, so this is going to be less than, or yeah, it's going to be that symbol with that under it. This is also closed, so it's going to be that symbol with this under it. Okay. Now, you might be recognizing that if there was an open circle here, and let's say there was a closed circle here, well, once again, it's still such that x is between -4 and -1, but this would be without an underline, and this would be with an underline. So the fact that this is an open circle means there's no underline, so you do need to be on the lookout for that. Looking at 17, the area A of the rectangle shown is described with the inequality, blah, blah, blah. Write and solve a compound inequality for that. Okay, well, let's remind ourselves that the area of any rectangle is length times width. And I think we understand that the area of this rectangle would be 1.5 times 4x. Now, in a sense, they're kind of giving us a nice clue as to what to do here. And that is to go ahead and just put 1.5 times 4x in the middle, because what we're seeing here is that anytime we see a capital A for area, it could be replaced with this, because this is the same as the capital A. So let's do that. We have 36. We will put this in between, and that's our situation. Now, it's the case that 1.5 times 4x is 6x, if you were to work that out. For my student watching, worst comes to worst, just do 1.5 times 4, and then you would realize that it's 6, okay, after doing the work. So then we have this scenario. Now, the thing about this is it's pretty easy to solve. I know it looks weird because you have some X shenanigans happening in between two numbers, but the bottom line is it's really easy. The general principle of getting X by itself still applies. And in order to do that, I think we understand that we would have to get rid of that red 6 in order to get that X by itself. So how could you get rid of the 6? Well, we could divide that by 6, but whenever you divide by 6, you have to divide everything by 6. Cancel. Next thing you know, you have 72 divided by 6, which is 12. 36 divided by 6, which is 6. And let's see, did we satisfy what they wanted? Write and solve a compound inequality for x. Yeah, so we just did that. Now, I am confident the teacher would accept this as the answer. Let's make sure we understand what this means. What this means is that we don't know what x is, but x could be any number between 6 and 12. All right. So, in other words, if x over here was any number between 6 and 12, well, then it would create an area that's between 36 and 72. So, that is that one. Let's take a look at the next one. Saw the absolute value thing. So, when solving absolute value equations, I'm just going to make it look like this because that's typically how it's written. The first step is to always get the absolute value part, which is this part, by itself on one side of the equal sign. Now, you might be noticing this is already by itself. So we don't have to worry about that step. However, if we were dealing with this, well, we would have to subtract the 3 from both sides first as step number 1, and then we would have that. So we don't have to worry about that. We can then split this. So it's 6 minus x equals 3, and 6 minus x equals -3. So that's how you do these. Once the absolute value part is by itself, you split it into two equations. The first equation is the normal looking equation where it's almost a replica of this, only without absolute value symbols. And then this equation is we're going to negativize. I made that word up. Do you like that one? We're going to negativize whatever is this number and put it here without the absolute value symbols. Then you solve it. Subtracting 6 from both sides would give us this. Dividing both sides by -1 would give us this. That's one of the answers. Subtracting 6 from both sides would give us this. Dividing both sides by -1 would give us this. That's the other answer. So x equals 9 and 3 right there. All right, that's that. I'm not really sure. I'm going to assume we don't have to do that. It could be laziness a little bit, but usually when I see big X's going through something on a worksheet, that means we don't have to do it. Graph the solution of the absolute value inequality on the number line. Okay, so this has been replaced with an equal sign. I'm going to assume the teacher is telling the students that they're not there yet. We're not at the point where we're going to be doing a problem like this. So instead, let's just treat this as an equal sign for now because that's a little bit more of a basic type of problem. So I'm going to assume that that's the reason for the equal sign. So let's go ahead and go through the motions. Now, remember how I said step number one is to get the absolute value part by itself. So it's almost like we're solving for the absolute value part. Now, again, how to get the absolute value part by itself? We have to get rid of all the other stuff that's not the absolute value part. And you have to start with the stuff that's far away. This is the thing that's far away. So we would be subtracting one from both sides. Next thing you know, you have this, and then dividing both sides by two would leave us with this. And now we're ready to do the split. This is the sort of normal version. This is the negativized version. Subtracting 3 from both sides gives us -2. Subtracting 3 from both sides gives us -4. Boom. Just crushed it. Unbelievable. So that's the answer to that one. And that is that. That's the whole worksheet. Hopefully that all makes sense. Thank you for those of you who watched it, for my student who's watching. Good luck on this assessment, and I will talk to you all later. Take care. Bye.